In this lab, what we're going to be looking at is the energy of the metabolic rate. And what we're going to be looking at this is going to be glucose, right? The metabolism of glucose. And we're going to use the gas laws to help us figure this out. We're going to use the gas laws to determine the number of moles of carbon dioxide. Going back to the ideal gas law, remember that P stands for pressure, V stands for volume, N is the number of moles, R is the ideal gas constant, 0.08206 liters, atmospheres, moles per Kelvin. So mole in Kelvin is going to be in the denominator for the unit. And then the T is going to be in temperature. Remember the units of Kelvin. You can calculate. You can measure the temperature in degrees Celsius. Add 273.15 to that, and that will give you the temperature in Kelvin. And what we're going to be doing in this lab is you're going to take I happen to be using a milk jug, and you could use probably a 2-liter bottle, and you're going to submerge that in the water. And I'll show you how to do that. And what you're going to do is you're going to completely fill the milk jug or the 2-liter bottle, whatever container you have, completely full with water. Put the cap on it, put it under water, open up the cap, and you're going to insert some type of hose or straw. Now what I have here is I have some straws here. And if you can pinch the end of that, I don't know how easy that is to see, and you can then insert it into another straw. What you've now done is you've actually made the straw a little bit bigger. All right, you're going to need this length because what you're going to do is you're going to blow into the straw, which is going to be into the jug, and that's going to displace the water. The volume of water that gets displaced is going to be equal to the volume of gas that you are exhaling out of your body. Okay, and so for the first couple of parts of this, you're just going to try to determine the number of breaths you make per hour. And I'm not going to make a video on that. That's pretty straightforward. But right now what I'm going to do is I'm going to show you how to set up and submerge the jug and how to insert the straws. If you happen to use straws, I happen to use a hose. I make my own maple syrup, and so I have all kinds of this hoses sitting around that I can use to collect the sap. I'm going to use this to determine the amount of volume that I'm going to displace with my breath. Okay? So right now we're going to move on into part 3 of the lab. Okay? Alright, now we're going to move on into part 3 of this lab. Alright, so first thing you're probably going to want to do is you're going to want to measure the temperature of the water. Alright, you're going to measure the temperature of water in degrees Celsius, add 273.15 to that, and that's going to get you into the temperature. That will convert the temperature into Kelvin. Alright. Now what I'm going to do is I'm going to completely fill this jug up with water all the way up to the top. Okay? So I'm going to fill it as far as I possibly can, all the way up to the top. Alright? So there. Now I filled that up to the top, and I'm now going to insert the cap on top of this. Now what I can do is I can completely submerge this underwater as such, and I shouldn't lose any volume of the water. The water is already up there. Okay? Now I know the lab says you can sit down. I don't have a tub large enough to put this jug in, and so that will be okay. And what I'm going to do now is I'll put my sap hose into the container. I'll take a breath, and I'm going to exhale into the hose, which is going to displace the water. Okay? So okay, so now I'm going to take the hose out, alright, and I'll put the cap onto the milk jug, alright, so as not to let water go back into it. And you can see that that's the amount of air that I put into the jug from that one breath. Alright, now for the next step, what we're going to do is we're going to use a measuring cup and fill back up to the fullness and determine the volume of that. Now you can either use a measuring cup, or you can use the graduated cylinder that I gave you. I'm going to use a measuring cup simply because that's a lot of volume and it's going to take forever to use a 50 milliliter graduated cylinder, right? So when I come back, we'll fill this up with water, okay? All right, once again, here's the level of my water right here, and I need to fill up to this, and I want to record the volume from here up to the top. So I happen to have a measuring cup here, all right, and I filled up to 500 milliliters, and I'm going to carefully add that to the milk jug. All right, so I'm going to just carefully add that to the milk jug. And I'm going to continue to do that until I get awfully close to the top. As I get awfully close to the top, I'm then going to use my graduated cylinder. All right, so you should use a graduated cylinder just to sort of top it off so that you can get as accurate a measurement as possible. All right. All right, so now what I've done now is I have filled up to this portion of my milk jug with my measuring cup. Okay, so since the graduations in the measuring cup are not all that accurate, I'm now going to use my graduated cylinder. So what I've done now is I filled it up to 50 milliliter mark, and I'm going to add as much water as it takes for the crest of the water to come to the very top of the milk jug. So I'm going to continue adding. I'm going to be very careful. If you spill some, it's still such a large volume. And so that appears to be completely full. And what I've added now is I've added 35 milliliters. Okay, so I kept track of how many milliliters of water I added. All right, and then to that I'm going to add 35 milliliters. That just happened to be for this milk jug and my breath. Okay, then what I'm going to do, I am then going to enter that value right here on table 2. All right, I'm then going to divide the volume I found by 1,000, and that will give me the volume of water in liters. Okay, so that's how you do the procedure part 3, where you're measuring the volume of gas you normally exhale during one breath. All right, now the rest is going to be simply calculations on how you do this, but you're going to want to repeat this trial, repeat what you just done 3 times. All right, take normal breaths, and you're going to want to average those breaths out. The average then is of the volume of water, which actually is going to be the volume of your air, or I'm sorry, the volume of CO2. I'm sorry, the volume of CO2. You're going to use that average volume, all right, for the remaining portion of the calculations. All right. As normal, if you happen to have any questions, feel free to ask me. All right. Good night.